Imagine this, getting power not just when the sun's out, but actually from the rain hitting your roof. Sounds a bit like science fiction, doesn't it?
It really does. But it's becoming surprisingly real.
So in this deep dive, we're unpacking exactly that rain-powered solar panels, and we're focusing on maybe an unexpected place, Caldwell, Idaho.
Right.
Our mission is to figure out, how this tech works, why a place like Caldwell makes sense, and what it means for homeowners, financially speaking.
And the source material we're diving into, it's full of data, real-world examples.
Hmm.
It really bridges that gap between the lab and, well, your roof. It gives you a practical look.
Okay, let's get into it then. How do these panels, how do they actually do that? You mentioned a dual mechanism.
Exactly. So first you've got your standard photovoltaic cells, pretty familiar tech. They grab sunlight, turn it into electricity. Efficiency there is up to about 22.5%.
Okay, standard solar stuff, but the rain part, that's the bit that grabbed me. There's this graphene layer involved. How does that work?
Yeah, the graphene layer is the real magic here. So when raindrops hit it, it creates this opportunity for an electron exchange between the graphene and the ions in the rainwater.
Electron exchange.
Yeah?
Like tiny little jolts of electricity?
Sort of, yeah. Think of it like the panel acting as a pseudocapacitor for a split second. The raindrop lands, creates a charge difference, boom, tiny bit of current generated. It's fascinating.
And that works even when it's pouring.
It does. It generates electricity during the rain. The efficiency is lower, mind you, around 6.5% under rainy conditions.
6.5%. Okay, so not the 22% of direct sun, but it's something when you'd normally get nothing.
Precisely. It means your solar setup isn't useless on cloudy, rainy days. It smooths out the energy production, especially in places with variable weather. That 6.5%, it's the key to all-weather operation.
Which brings us back to Caldwell, Idaho. Why? I mean, you hear Idaho, you maybe don't immediately think ideal for rain power. It's semi-arid rain.
It is, technically. But here's the interesting part. Caldwell gets about 211 sunny days a year. That's actually more than the U.S. average.
More sun. Okay.
Yeah, and while the total rainfall isn't huge, only about 11 inches annually, it's concentrated. It mostly falls in winter and spring.
So when the sun is maybe less intense anyway.
Exactly. You get this complementary effect. Plus, you factor in low hurricane risk, not much snow, only about 8 inches a year on average. It all adds up to making solar, even this hybrid type, a pretty good bet there. Despite the semi-arid label, you're optimizing for both sun and rain cycles.
Right. Let's talk money then, because that's always the big question for homeowners thinking about this stuff. These hybrid panels, they cost more upfront, don't they?
They do. Estimates put them around $3.10 per watt. Compare that to maybe $2.46 per watt for traditional solar panels.
So quick math, a typical 5 kilowatt system, that's like $15,500 for the hybrid versus $12,300 for traditional, before any incentives.
Correct. That's the ballpark figure. But, and this is crucial, you have the 30% federal tax credit. That ITC makes a big difference.
Okay, run the numbers with the credit.
So that $15,500 hybrid system, after the 30% credit, comes down to $10,850. It closes the gap considerably.
Still more than traditional post-credit, but closer.
Yes, about 26% more upfront cost after the credit. But remember what you're getting for that extra cost, energy generation, during those rainy Idaho seasons. It boosts your total annual output.
Is there data on how much extra energy we're talking?
Yeah, there's a case study referenced an 8-kilowatt residential system. On rainy days, it was adding an extra 8 to 12 kilowatt hours.
Wow, okay. That's not insignificant, especially satisfying on a gloomy day, I bet.
Definitely. And that study projected annual savings of about $1,200, beating to a payback period of around 9.2 years for the system.
9 years, okay. Still a wait, but that $1,200 annual saving helps.
And keep in mind, electricity rates in Caldwell are a bit higher than the Idaho average, about 4.6% higher. Plus, rates across Idaho are generally rising around 4.9% annually. That context makes the long-term investment look, well, more attractive.
Makes sense. But it can't all be perfect yet. What are the hurdles, the challenges stopping everyone from getting these tomorrow?
Good question. The main technical limitation right now is still that efficiency gap. 6.5% for rain versus 22.5% for sun. It means you might need a larger roof area, a bigger installation, to get the same total power as a sun-only system.
Okay, space could be an issue for some. What else?
Well, the graphene tech itself, it's still kind of new, mostly in prototype stages for these applications. That means potential maintenance needs might be higher initially, and finding local technicians with expertise could be tricky.
Right, the early adopter challenges.
Exactly. But looking ahead, there's exciting stuff on the horizon. Research is aiming to boost that rainy day efficiency, maybe up to 12% by 2030, through better graphene conductivity.
Doubling the rain efficiency. That would be huge.
It would significantly improve the economics. And there's also work on AI-driven systems for monitoring and predictive maintenance, which could cut down on operational costs and hassle for you.
So, pulling it all together, what's the takeaway here for someone in a place like Caldwell or maybe somewhere with similar weather patterns?
The core idea is that these rain-powered hybrid systems offer climate resilience. They let you leverage both the sun you get and the rain you get. It's a more complete energy solution for variable climates.
And those federal incentives, they really are key to making the current costs more manageable for homeowners, speeding things up.
Absolutely. They bring that payback period into a more reasonable time frame for many people.
So a final thought then. Given that electricity isn't getting any cheaper, those rising Idaho rates you mentioned,
Right, increasing about 4.9% a year.
how should we think about these hybrid systems? Is it just about being green, or is there a bigger strategic element for homeowners?
That's the really interesting question to leave people with, I think, is investing in this kind of hybrid solar potentially less about just sustainability and more about a strategic move, a step towards, greater energy independence and locking in your energy costs long term. What does that mean for your home and your financial planning?